Hi, my name is Brian. I'm a PhD student at ETH Zurich, and this is my collaborator Sabri, who is a PhD student at Stanford. In the following minutes, we're very excited to share with you something that we've been working on recently. It's called DCBench, a benchmark for evaluating data-centric AI systems. Let's begin. So if you go to datacentricai.cc/benchmark, you will arrive at this page, which we envision as the main hub of all the benchmark-related resources. So apart from some background info, it contains some quick get started guide to, with a few steps that you can follow along, as well as an overview of the tasks. So each one of these tasks represents a single pain point around the entire data-centric AI workflow. So currently we have only 3, but we definitely plan to keep on adding more in the near future. So apart from that, we also offer this documentation page, which contains some information about the tasks and about the internals of the API. And finally, the main page is for all the code, which is on GitHub repo. And as this is a relatively new project, we would definitely appreciate you can take time to submit any issues or give us any feedback. And finally, what I want to show you is this notebooks page, which contains several notebooks that could walk you through, again, for every specific task, what would be the steps to get started quickly. And right now, we're going to look at one specific task.
So I'm going to be giving a quick demo of DCBench, which is this data-centric benchmark that we've been putting together over the last few weeks. In particular, I'm going to be diving into one task, slice discovery, and demonstrating how DCBench makes it possible to evaluate methods that are designed for data-centric tasks, like slice discovery. So to get started, let's just import DCBench, and let's list the different tasks that are supported by the benchmark. And so you can see that there are 3 right there, and in the middle we have slice discovery. So what is slice discovery? Slice discovery is the task of identifying meaningful subgroups of data points on which a model is underperforming. And so what we're trying to do with DCBench here is evaluate different algorithms that try to solve the slice discovery task automatically. We're going to call these slice discovery methods. Let's dive in one level deeper. What we'll notice is that within DCBench, each task has a collection of problems underneath it. What is a problem? A problem is just an instance of a task. So to better understand this, let's discuss a little bit more about what the format of the slice discovery task is. So the way this works is that the slice discovery method will take in as input a data set, and as well as a model that we're trying to audit. And it'll output basically binary indicators specifying different subgroups or slices on which it thinks the model is underperforming. We're going to then check this or reference this against the ground truth slice that we know the model is underperforming on. So when we list out the problems right here, we see that there are dozens of different problems underneath the slice discovery task, and that they're on different data sets. They're also on different slice categories. They also have different targets. The target is basically just what that model was originally trained to do. So we're going to focus in particular on this task right here. A model was trained to detect food, and it turns out the model was underperforming on this subclass of food, hay. The task for the slice discovery method is to automatically identify that this subgroup of food is underperforming. What we're going to do is grab this problem specifically by its ID and list all of the different artifacts that are included in the problem. An artifact is basically just some piece of data that is necessary for solving the problem. So you can see that we have the model, which is just the model that was trained to detect food and is underperforming on hay. We have the predictions of the model cached away, so we don't have to compute them ourselves. We have a base data set, so these are just the images that the model has actually been trained on and is now being validated on. So one of the key things is that DCBench makes it easy to lazily load these artifacts into memory and even to download them. So when you install DCBench initially, we don't download any of these artifacts at that point in time. They get downloaded lazily as you access them. And so what we can do is just index into the problem and grab the base data set. And you can see the base data set here, this is just ImageNet. In addition to just this data set, we also have different artifacts. So for example, if we go in, we can take a look at a model, and you can see that there's this vision classifier. It's just a ResNet that was trained to classify food on this data set. So with the slice discovery problem in hand, we can go on to try to solve it using a couple of different slice discovery methods. So we'll start out with a simple slice discovery method that just returns the confusion matrix and doesn't do anything more in terms of trying to discover slices. When we run a slice discovery method on a problem, what we get back is a solution. One thing that you'll notice is that a solution, like a problem, is just a container of different artifacts. We can inspect that container and load those artifacts into memory. So here you can see that we basically have specified some predicted slices for each of the different IDs in the data set. We can then go on to evaluate that solution and get some metrics. We'll notice that we didn't do too great on this task with this simple method. So we can try something a little bit more complicated, and we'll evaluate this solution as well. Here we did quite a bit better. Finally, to bring things full circle, we can actually take a look at the slices that were predicted, visualize them, and confirm that indeed the second method did recover the slice that we were looking for, which was A. Great, so thanks for tuning in. Hopefully this was a helpful overview of what DCBench enables. Again, it's still early days, so we're looking for lots of feedback. If you have a moment, please go ahead and pip install the package and let us know what you think. Thank you.